So here we are. We're looking at my little work area, and I'm playing with things like hemp thread, hemp string actually, and other stuff like Elmer's glue. This is like very low tech, low infrastructure requirement type material here. Okay, and I took some of that string apart so that I could see, how small a string I could take off of there. So I can take one of these, or both of these, and wrap it. This is a piece that I put some super glue on, right? The crazy glue. Um, and it's taken the place of my shellac because I can't make shellac right this minute. I'm sick. So so forgive me, but it works about the same way. It kind of looks the same way, um, and acts the same way. Dries real fast and stuff. And I make it with acetone and alcohol, so it dries real fast and hard. And this crazy glue, this will burn, right? The shellac is more fire resistant. It's just cellulose. It burns, but doesn't burn like plastic does. It burns like wood does. Um, and and I can make it flame proof. So with other additions. So we're playing with this to see what we can do. This is, look at this. That's my piece of string, and it's a stick now, right? And I can bend it, I'm sure, and break it if I not break it. It'll just bend. It won't come apart because those fibers stretch all the way from one end to the other. They're single fibers wrapped together. And they're one thing, and they don't come apart real easily. They don't break like cotton thread does. Um, and so I got another one here that I put some Elmer's glue on, and I'm letting it dry. It takes a little longer to dry. But then I'm gonna put this on the outside, the glue stuff on the outside. And then I'll have something that's kind of semi-flexible. Huh? Pretty hard like this, but more flexible. Okay, so I'm just playing with the thing. Now this, I can make it much, much, much stronger by wrapping those other threads around it. Okay, and these are going one direction, from this way to this way. So it would screw in backwards, right? It's going backwards, counterclockwise. Um, and so if I wrap this one around it clockwise, bump, 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 what happens is I have a coil going that way and a coil going this way. And they work together to create a, a non-breakable, very, very, very strong piece of biological plastic that can be used like steel. Now, here is a piece of silver, sterling silver. I made jewelry out of it, and this one didn't work out, so I just left it because silver's still silver. I did this many years ago, probably 10 years ago, so I've got this, and that's how much it takes to bend it. Okay, and if I go boom and bend it back, and bump and bend it again, in a couple of minutes it breaks. Hang on, let's look at this guy. This is pretty firm. It's straight and solid and hard. It's like spring steel. This is, hold on please, Joe, I'm sorry. This is a piece of, like, twist tie, right? Very bendable wire. I can bend that about 10 times. Can't focus my damn camera anymore, but I can bend that wire 10 times and it'll break. I can bend my piece of biological plastic, and not this stuff, okay? This is just make-believe, pretend that I've got shellac here. And the shellac does the same thing. It dries the same way, and better because it actually binds with those hemp fibers in a very natural way, because the shellac is made out of lignin, and lignin is what makes woody plants hard and stand up straight and stuff, like trees, right? It's what makes trees and wood hard. So this wood here is about I maybe 3 on the most scale of hard. It's a little harder than my fingernail. I can maybe almost scratch it with my fingernail. It's just 2.5. And that's about what we have here. This is about as hard as a piece of wood, and flexible like a piece of wood. And this one is going to be even more flexible, and it will actually, I'm going to use the Elmer's glue on this, because I'm not going to use the bigger threads. What I'm going to use is this stuff. This came on a string of beads, pearls, right? Nice little black pearls, beautiful little black pearls, naturals. They're not seed pearls. And I buy them on eBay for a few dollars. If you know what you're looking for, you can find them. I buy durable goods, including tools and gemstones of the precious variety. So only black opal, diamonds, and rubies and sapphires, and pearls. I love pearls. Look at that. Isn't that beautiful, man? And they're all different. They're not all perfect, and these are like straight from the South Seas. So, anyway, it's got silk holding it together. So I'm going to take this piece of silk, this silk thread, and use it to wrap in the clockwise direction around my counterclockwise wrap string here. And I'm going to put Elmer's glue on first, right? So I'll put the glue on and run that stuff this way and wrap it, boom, 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 by twisting my little thing around and just, wrapping it up. And it'll wrap in the opposite direction of this other coil. And it'll sort of fit in between the coils here. And it'll be the next number of Fibonacci number, however many of these coils there are, little twists there are. There will be a Fibonacci, the next Fibonacci number up of them, and you figure that out by figuring out how many there are there, and multiplying times 1.6. And so my thinner thread will go around it instead of 100%, goes through 160%. 1.6169. And everything grows along those same numbers, the same ratio of numbers, 1.6. The number of atoms in the universe increases each day by 1.6. It's called the golden ratio. And those things fit together, right? So that they function together. And then I'll have a stick, much like a real stick, that has coils and fibers that go in both directions. And that's what makes wood and plants, woody plants, stand up straight. And my shellac is the lignin that makes them do that. Shellac is the lignin from inside of bamboo, the hardest wood on earth. It's kind of brittle, right? Bamboo is. But that lignin carries its hardness into shellac, and they've been using it in China as a natural plastic for time out of mind, as they say, since written history began. Because they're very, very, very clever people, those Chinese. And they've been civilized a very, very long time this time around. And they used things like this. They had natural gas piped in to their ceramic factories 3,000 years ago using bamboo. Okay, so I can take bamboo and drill little holes in the sections, right? The sections of bamboo are hollow. I drill a hole at the top and a hole at the bottom. I get Elmer's glue coming off of my fingers. So I drill a hole at the top and a hole at the bottom, small one, about this size hole, right? Little ones. And I put shellac in there just by submersing the entire piece of bamboo in there, and it fills up that chamber, right? And it's a liquid. It's not solid at all. It's just a liquid like alcohol. It is alcohol and some acetone, and this shellac stuff, which is lignin, and the cellulose from inside of bamboo. So it's a little gummy, foamy looking type stuff. We get the same thing from inside cannabis. The cellulose from inside cannabis, along with this stuff, makes vastly superior paper to wood paper. And it requires no pollution to do that. You just add water, right? Or a little shellac if you want to turn it into a plastic, because See, I can make, I have my first attempt at making paper here. And it didn't survive well, because not because it wasn't good, but because it's been banging around here while I've been sick. So it didn't come out as well as I hoped it would. And so I'm using this instead as my wing. And this is a piece of coffee filter paper and Elmer's glue. And I now have a real wing that will fly. This will fly nicely. And what I'm going to do is use my little extra strings here for the kite to attach to the tripod of the kite. This is kind of something I'm looking at, because I can use this stuff like nuts and bolts, right? This can stop in a hole, boom, and not go through. And then I can pull it tight on the other side and make one of these little knots with a machine, right? That's kind of how you do knotting when you do knotting of string or metal. That's what these are for. I pull it tight, and I can put that through a hole that's not going anywhere. Something like this thing. And pull it tight so that knot is a very small thing, but it's still way bigger than the hole, because the hole's only big enough to hold the string, and then you put like a grommet around there, something that gives it a little more meat around where the knot's going to be, and you pull it tight, and I can pull it around my structural parts like this and tie it in place with another knot. Boom, boom, real quick, like riveting steel or aluminum. And this here, I said it wasn't rippable, but I did actually rip it the other day a little bit when I was flexing it to soften the plastic up a little bit. This is just Elmer's glue at this point in time. So it's still real flexible. When I'm done with this one, with the string and the rewrap on this, it's not going to be very flexible anymore. It's going to be stronger than my it's already stronger than my silver. It's just about as hard as a piece of wood at the moment. And when I'm done with the silk going in the other direction, it'll be as strong as a stick, right? It won't bend so much because it's really, really strong. But instead of breaking after a few minutes of flexing, it'll flex and flex and flex 50,000 times more than a piece of steel could do. And that's what I'm going to make my plane out of, my airplanes. Out of all organic materials with no poisons. No poisons. We can't do that if we want to have a planet to leave our children. We have to change our evil ways, or we won't have a planet to leave our children, folks.